In the last video, we solved the modulus inequality, mod of 1 minus 2x less than 5. In this video, we're going to look at the graph of the modulus of 1 minus 2x. But before we look at this graph, we're going to consider a simpler graph. That is just a graph of y equals 1 minus 2x without getting the modulus. So how do we graph this? Well, this is a linear function of x. So its graph is a straight line. We could write it in the form y equals mx plus c. This is called the slope-intercept form. The coefficient of x is the slope, it's called m. The y-intercept is plus 1. So the line cuts the y-axis at plus 1. So when x is 0, y is 1. So that's a point on the line. The slope of the line is minus 2. That means if we pick any point on the line and increase x by 1, say we pick this point here. If we increase x by 1, then we have to go down 2 units to meet the line. And we can get a second point that way and draw our line. So the slope is minus 2 because we have to go down 2 units. Anyway, another way that we could do this is just pick 2 points on the line. You know, let x equal any number we like. If we let x equal 0, we get y equals 1. Well, we just get the y-intercept. But we could let x equal 2, for example. If we let x equal 2, we get y equals minus 4 plus 1, which is minus 3. We can get this point. And once we have 2 points, we can draw our line. Now let's consider the modulus of 1 minus 2x. Notice here that at x equals a half, y is equal to 0. If we plug a half in here, we get minus 2 times a half is minus 1, plus 1 gives us 0. So this is where the line cuts the x-axis. This is the x-intercept. Let's consider values of x that are less than a half when we're trying to graph the modulus of 1 minus 2x. Well, we could say less than or equal to a half. Okay, for example, let's pick a value. Let's pick, say, minus 3. Okay, so we're just going to look at values less than a half. Well, we might just look at one value. That might be enough to get the point. If x equals minus 3, what is y going to equal? Now I'm going to look at this function here. Not y equals 1 minus 2x. Y equals the mod of 1 minus 2x. So we want the mod of 1 minus 2 times minus 3. Well, that's the mod of 1 plus 6, which is 7. So we have the mod of 7. But the mod of 7 is just 7, because 7 is positive. So, if x equals minus 3, then the mod of 1 minus 2x is plus 7. Same as for the function y equals 1 minus 2x. And you can see that's the case for any value of x less than a half. Like if you take x equals minus 1, and if we get y equals the mod of 1 minus 2 times minus 1, we get the mod of 1 plus 2, the mod of 3, which is just 3. So the value of the function at minus 1 is 3. So you can see the mod of 1 minus 2x is equal to 1 minus 2x for values of x less than or equal to a half. If x is equal to a half, then this quantity is 0. Well, the mod of 0 is just 0, of course. So it's true for x equals a half. It's true for any values of x less than or equal to a half. However, things look different for values of x greater than a half. So let's take a value greater than a half. Let's look at x equals 2. This value here. Well, y is the mod of 1 minus 2 times 2. So we're working with our new function now. Well, this is the mod of 1 minus 4, or the mod of minus 3. But the mod of minus 3 is plus 3. For our old function, when x was 2, y was minus 3. But for our new function, y equals the mod of 1 minus 2x. When x is 2, y is plus 3. So you can see what's after happening. For our new function, we have to reflect this part of the graph through the x-axis. Similarly, you'll see it for other values. For example, x equals 4. For this function here, y is actually minus 7. But for our new function, y will be plus 7. So we write it like the following. For values of x greater than a half, our new function, the mod of 1 minus 2x, is minus our old function. We have to minus the old function. In other words, we have to take the values that we get in our old function, which are negative for values of x greater than half, and just minus them, make them positive. So basically we're just reflecting the part of this graph which is below the x-axis through the x-axis. So we get this v-shaped function. Now let's use the graph to solve this inequality here. We want to find the values of x for which the mod of 1 minus 2x is less than 5. Or since we're calling this y, we want to find the values of x for which y is less than 5. So to do that, we go to 5 on the y-axis. And we just go across from 5 and down. Now we can see that for values of x lying between minus 2 and plus 3, we get values of y that are less than 5. So values of x strictly between minus 2 and 3. So for all these values, if you go up to the curve, you will get a value of y that is less than 5 for all values in this region here.